Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve question bank. Question bank in the BEE subject module 2 problem, that means network theorems and network topology. In that part A, problem solving and critical thinking questions. So total 10 questions in this first question. Calculate the current flowing through the 3 ohms resistor using Norton's theorem. So in a given network. So here, what are the elements in a network? So four resistors and one voltage source, 4 ohms, 5 ohms, 2 ohms and 3 ohms, and 20 volts is the voltage source. Here you need to calculate 3 ohms resistor current flowing through the 3 ohms resistor. Here 3 ohms is the load resistance, RL. RL means where you want to find out the current in a network. So load resistance is 3 ohms. Here to calculate the current flowing through the 3 ohms resistor, we have different techniques. Mesh analysis is one technique, nodal analysis one technique, Thevenin's theorem, Norton's theorem, and reciprocity theorem also. But here, particularly in the question, they have mentioned Norton's theorem. Using Norton's theorem, determine current flow into the 3 ohms resistor. So here we have total 4 to 5 steps here. So you have to follow the steps. Step 1, first determine the load resistance. What is the load resistance here? RL equals to, first RL equals to, find out the load resistance. RL equals to 3 ohms, where you want to find out in which current is to be calculated, the resistor in which is calculated. RL equals to 3 ohms resistor. And second step, first what is the equivalent circuit for Norton's theorem. Now here, so solution for this. So now equivalent resistance. Here what is Thevenin's theorem? Thevenin's theorem states that number of voltages in a linear network. This is a linear network. In a linear network, number of voltage sources, this number of voltage sources and current sources and resistors are replaced by single equivalent circuit. That single equivalent circuit consists of current source in parallel with resistance. Here current source in parallel with resistance. Now here this complete circuit and this complete circuit is same according to the Norton's theorem. Now reconnect the load resistance RL and RL, 3 ohms resistor, same. Now here you can verify, here this current and this current is same, means Norton's theorem is verified. So from this we can say that 3 ohms resistor current, first determine in this IN and after that N. So step 1 in the Norton's theorem, so determine the load resistance, that is RL, and second step is in that first convert into the equivalent Norton's equivalent circuit. That equivalent circuit is current source in parallel with resistance and reconnect the load resistance. So next second step is find out the IN. This IN value find out, and then RL value is 3 ohms load resistance. First there are again steps in this sub steps. So in this to find out the IN, first remove the load resistance from a given circuit, short the load terminal and calculate that short circuit current. So here is the circuit. So in this, first remove the load resistance from a given circuit. First draw the circuit. So here I am drawing the equivalent circuit, this one and this one. Actual given circuit I am drawing this one and this one. Now here 20 volts and this is 4 ohms and this is 2 ohms and this one is 5 ohms and this one is 3 ohms. Now here in this, remove the load resistance from a given circuit. That is step 1. To find out this one, remove the load resistance from a given circuit. Here remove this load resistance and short these load terminals. Remove the load resistance from a given circuit, short the load terminal and calculate that short circuit current. That short circuit current is known as IN, that is this one. So there are steps. First, determine here we need these three parameters to calculate this current flowing through 3 ohms resistor, I 3 ohms resistor. So IRL is okay. First find out IN, then RN, then find out the RL. Now here, remove the load resistance from a given circuit, short the load terminal and calculate the short circuit current. The short circuit current is known as Norton's current, that is represented with IN. Now here, so here how mesh analysis. How you will calculate that short circuit current? This short circuit current can be calculated from the mesh analysis. This is the I1 and this is the I2. So what are the steps? Determine possible number of meshes and assume the mesh currents I1 and I2 in clockwise direction. Mesh 1 and mesh 2, two meshes I1 and I2 in clockwise direction, and apply KVL in each mesh. So in the mesh 1, if you apply KVL, so 20 is the rising voltage and minus 4 I1 and 5 into I1 minus I2. This one, equation number 1. Now in the second mesh equation, 9 into what about 9? So 5, 2 and 3. Next, so 5 into I2 minus I1, this one. Next, 2 into I2 and plus 2 into I2. This one here. Now if you simplify second not mesh here, if you simplify this one, so 9 I1 minus 5 I2 equals to 20, this one. And second mesh, if you apply KVL in this, 5 into minus 5 I2 minus I1 minus 4 I2 equals to 0. This is a short circuit. There is no resistance. Remove the load resistance. Now here, remove the load resistance and short circuit. No voltage drop. Short circuit voltage is 0. And this current, calculate this current. Now minus 5 I2 minus I1 minus 4 I2. So minus 5 I2 minus I1, and this one is the 4. Now minus 5, this is 2, sorry. This one is 2. There is a wrong in this minus, this is 2. So voltage across this 5 ohms and voltage across this 2 ohms, not 4 ohms. And 5 minus I2 minus I1 minus 2 I2 equals to 0. Minus 5 I1 plus 7 I2 equals to 0. These are the two equations. If you solve this, you will get I1 equals to 3.69 and I2 equals to 2.63. Now here we have two mesh currents I1 and I2. Here I2 current is this short circuit current, and this short circuit current is known as Norton's current. So this is the Norton's current, 2.63 amperes is the Norton's current. We determine the Norton's current, and remaining parameter is the RN. So determine that one, step 3. And so for this also same, remove the load resistance from a given circuit first to determine the RN. So same thing. So this one R1, R2. So this one 4, 2, 5 and 20. And this is the load resistance 3. So here from this, remove this load resistance and short this load terminal and calculate this open circuit voltage. Now if you see this one, so remove this load resistance and short circuit voltage source is replaced by short circuit, this one, and calculate this R equivalent. So this R equivalent is known as Rn, and this Rn is this one. So first, so to determine the Rn, Norton's resistance, remove the load resistance from a given circuit, voltage source is replaced by short circuit and current source is replaced by open circuit, and calculate that open circuit terminals equivalent resistance. That equivalent resistance is known as Rn. So same thing here. So first, here this is the short circuit and 4 ohms, this is 5 ohms and this one. Here 4 and 5 are connected in parallel, again in series with the 2 ohms resistor. So to calculate, 4 and 5 are connected in parallel and in series with the 2 ohms resistor. So if you simplify this, you will get 4.2 ohms. Now here this is 4.22 ohms, and this one is 2.63 63 amperes. Now we have Norton's current, Norton's resistance, and load resistance. From this, we can determine the current flowing through this load resistance, 3 ohms resistor. Now, here, how you will calculate this current flowing through the 3 ohms? Two resistors are connected in parallel, and total current is flowing, ion current is flowing in these two parallel branches. Now, here for that case, IL equals to this current flowing through 3 ohms resistor equals to IN, RN, opposite branch resistance divided by total resistance RN plus RL into total current IN. This one. This is the formula for load resistance current. IL equals to this load resistance current IL equals to RN by RL plus RN into IN. Now here IN equals to this one. IL equals to this Rn equals to 4.22 divided by RL equals to, what is the RL value? RL value equals to 3 plus, and this one is 4.22, and IN is the 2.63 amperes. So if you calculate this one, that value equals to 1.53 amperes. Now current flowing through this 3 ohms resistor using Norton's theorem is the 1.53. Otherwise, you can calculate from the mesh analysis also I1 and I2. This I2 current is the current flowing through the 3 ohms resistor. If you do that, you will get the same value, I2 value 1.53. This is the first problem. Calculate the current flowing through the resistor using Norton's theorem. So first convert that given circuit into equivalent, single equivalent circuit. That single equivalent should be current source in parallel with the resistance. Again reconnect the load resistance. That load resistance current is the current flowing through the 3 ohms resistor. So to calculate the IN, remove the load resistance from a given circuit, short the load terminal and calculate the short circuit current. And second one, to determine the short circuit current is known as Norton's current, that is IN. And this to determine this IRN. So remove the load resistance from a given circuit and voltage source is replaced by short circuit. If any current source is there, open circuit that current source and calculate that R equivalent. That R equivalent is known as Norton's resistance RL, and substitute in this. Now from this current division rule, we can determine the current flowing through the load resistance value. Now second problem, same problem. Calculate the current flowing through the 3 ohms resistor using Thevenin's theorem. Same problem, same values. Now here using Thevenin's theorem. Now here same circuit, 4 ohms, 5 ohms, 2 ohms, 3 ohms and 20 ohms. This one 3 ohms resistor current 1.53. Same answer we will get from the mesh analysis, from the nodal analysis, from the Norton's theorem, from the Thevenin's theorem, and from the reciprocity theorem. Anyway, same answer we will get, but procedures are different, theorems are different. Here solution for this, first convert that circuit into the single equivalent circuit. Norton's equivalent circuit is the current source in parallel with the resistance. Thevenin's equivalent circuit is the voltage source in series with the resistance. So what is Thevenin's theorem? Number of voltage sources, current sources and resistors are replaced by single equivalent circuit. The single equivalent circuit consists of voltage source in series with the resistance. Here voltage source in series with the resistance means same thing. RL value is 3. So first step is determine the RL value. Determine load resistance here, where in which current to be calculated. Here 3 ohms resistor is the RL. RL equals to 3 ohms resistor. Now here we need to determine VTH and RTH. There are steps for VTH and RTH. So now let us find out VTH. Find out the VTH. There are again steps. So total 3 steps. Remove the load resistance from a given circuit, calculate the open circuit voltage, and that open circuit voltage is known as the VTH, Thevenin's voltage, and this is the circuit. First draw this circuit. And this is 3 ohms, this one is 2 ohms, and this one is 4 ohms, 20 volts and 5 ohms. So here to determine VTH, First remove the load resistance from a given circuit. So first remove this one. Remove the load resistance from a given circuit and calculate the open circuit voltage VOC. Calculate the open circuit voltage. That open circuit voltage is known as VTH and substitute in this like Thevenin's Norton's theorem. How you will calculate this using mesh analysis? Here open circuit. So remove the load resistance from a given circuit means. So from the mesh analysis, what are the steps? First determine possible number of meshes, mesh 1 and mesh 2. Mesh 1 current is I1 that is in clockwise direction and mesh 2 current is I2 in clockwise direction. Assume the mesh currents I1 and I2 in clockwise direction. That's the second one. And third step in the mesh analysis, apply KVL in each mesh. So what are the KVL equations here? So 20 is the rising voltage minus 4 I1 and 5 into I1 minus I2. But here we need to keep it in mind, there is a open circuit, I2 current is 0. Because always open circuit current is 0, keep it in mind I2 current is 0 because open circuit current is always 0 and short circuit voltage is always 0. Now here I2 current is 0. So if you know the I2 value, then you can determine easily I1 value. I2 current is 0 because of the open circuit at the load terminal. So I2 equals 0 and substitute in the mesh equation 1 and you will get I1 value. Here I1 equals to, so next I2 equals to 0. Here 9 I1 equals to 20. I1 equals to 20. Next second equation, minus 5 I2 minus I1, this I2 equals 0 and 4 I2, this I2 equals 0 and this is the voltage. Apply KVL, algebraic sum of total voltages in a loop equals to 0. Now here minus 5 I2 minus I1 minus 4 I2 plus VOC equals to 0. Here V2 I2 equals 0 and if you after that this I1 equals to 20 by 9, this one. This substitute in this, you will get VOC. This VOC is known as open circuit voltage. That open circuit voltage is known as Thevenin's voltage and substitute in the equivalent circuit, single equivalent circuit. Now here minus 5 I1 minus 7 I2 and VOC, this one, and this I1 is this one. Substitute in this. You will get I1 is this one, 20 by 9 is that is 2.22 and this VOC is the, this is ampere and this is 11.11 volts. Now here we got VTH. VOC is the 11.11 volt and this 11.11 volt indicates that is Thevenin's voltage. This is 11.1 volt. Now we got Thevenin's voltage and determine RTH. What are the steps to determine the RTH? Same steps as we calculated in the Norton's theorem. So same, remove the load resistance from a given circuit. Voltage source is replaced by short circuit. Current source is replaced by open circuit and calculate that equivalent circuit. That equivalent circuit resistance is known as the Thevenin's resistance. Determine RTH. So now same thing, draw the circuit. This one and this is the Thevenin's 20 volts and this is 4, this is 2 and this one is 5 and this is the 3 ohms. Remove the load resistance from a given circuit, first one, and short this load terminals. So short this source terminal. Voltage source is always replaced by short circuit and current source is replaced by open circuit. Now this equivalent circuit, R equivalent equals same thing, 4 into 5 in parallel again in series with the 2 ohms resistor. Now here 4 into 5 divided by plus 4 plus 5 plus 2 equals to 4.22. This is 4.22 ohms. RTH, RH, RN and equivalent resistance all are same, that is 4.22. Now we have load resistance, Thevenin's resistance, and Thevenin's voltage. So from this we can easily, this is simple circuit, we can easily determine 3 ohms resistor current, that equals to VTH equals to this, VTH equals to IL equals to VTH divided by RL plus VTH equals to 11.11 divided by this load resistance 3 plus 4.22, that is 1.5, same 1.53. In the Thevenin's theorem, in the Norton's theorem also we got same value 1.53. In the Thevenin's theorem also we got same value 1.53. If you use nodal mesh also you will get same value. Now second question over. Third question, in a network consists of parallel branches, 3 parallel branches, and first across is defined as first branch across is defined as 5 volts in series with the 5 ohms, and second branch is 7 ohms, and third branch is 10 ohms in series with 4 ohms, and apply superposition theorem and to determine voltage drop across 7 ohms resistor. Now here this is the circuit. So same thing. So first total how many branches here? 3 branches. This is the first branch, and this one is the second branch, and this one is the third branch. The first branch, what the 5 ohms and 5 volts are connected in series. This is the 5. And second branch is 7 ohms only. There is no voltage source. Next, in the third branch, 10 volts and 4 ohms are connected in series. Now here apply superposition theorem to determine the voltage drop across the 7 ohms resistor. Here we can apply superposition theorem. There are 2 limitations. To apply superposition theorem, there must be at least 2 sources. For single source, we cannot apply superposition theorem. That is the limitation of superposition. Here we have 2 sources, then we can apply easily superposition theorem. And another thing, here we need voltage drop across this 7 ohms resistor. First determine the current flowing through the 7 ohms resistor. After that multiply with 7 ohms resistor current. Now how you will, what is the superposition theorem statement here? If you know the statement only, then only you can calculate the superposition theorem. You can calculate the 7 ohms resistor. Now here superposition theorem states that in a linear network, total response equals to sum of the individual responses. What is meant by resistance? Here response may be either voltage or current. Here the response is voltage drop across the 7 ohms resistor, means here response equals to 7 ohms resistor. Here the response 1 and response 2 is calculated from this 2. And here 5 volts and 10 volts are active. First 5 volts and 10 volts are active, and calculate this voltage across the 10 ohms resistor. So means first calculate that current response, then you can not 10 ohms, 7 ohms, sorry. This is the, now here in the first one, here in the first circuit, so 5 volts active and 10 volts deactive. That means short circuit. Voltage source deactive means that is 0 volts. 0 volts means that is short circuit. Here it should be 0. Only one source is active, remaining all sources are deactive. So deactive means that is 0 volts. 0 when voltage source voltage value is 0, when it should be in short circuit condition only. Now 5 volts active, and calculate this current flowing through 7 ohms dash. After that, if you multiply with 7 ohms with that current, you will get the voltage across the 7 ohms resistor. And second case, this one, so 10 volts active, this 10 volts active and 5 volts is deactive. And 5 volts is deactive means this is short circuit, and this one is 0 volts. Now here 5 volts active, 10 volts deactive. Here 10 volts active, 5 volts deactive, and calculate the current flowing through the 7 ohms double dash and multiply with 7, and you will get the total 7 voltage across the 7 ohms. This is the current flowing through the 7 ohms when two sources are active. Now here 5 volts and 10 volts are active. Both are active. Now here according to the superposition theorem, I7 equals to, when two sources are active, that response current equals to I7 dash plus I7 double dash. Total response equals to sum of the individual responses. How many responses here? Two responses. Response 1 and response 2. Individual responses are depending on the number of sources in the network. Here we have only two sources, so two individual sources. At a time, only one source should be active, remaining all sources should be inactive. Here 5 volts and 10 volts active. So at that case, I7 dash and 10 volts active and 5 volts deactive. At that case, I7 double dash. So these two are individual sources, individual responses. When two sources are active, that condition is the total response. Total response equals to sum of the individual responses. That is a superposition theorem statement. Now here, first determine individual responses first. Here, if you multiply with 7, you will get V7 equals to V7 dash plus V7 double dash. Voltage across this 7 ohms equals to voltage across 7 ohms dash plus voltage across this 7 ohms double dash. Now, if you same 7 into this one, 7 into this one, and 7 into this. First, calculate the current flowing through this individual response one, I7 dash and I7 double dash. So, for this first particular circuit one, here, if you apply KVL, then you will easily calculate 7 ohms. So, 5 into 5 minus 5I1, this one, and this is 7 into I1 minus I2, this is 1. And next, the simplified equation for this one, 12 minus 7I2 is equal to 5. And second mesh equation, 7 into I2 minus I1 and minus 4I2 equals to 0. The simplified equation equals to minus 7I1 equals to plus 11I2. Now, if you solve these two equations, equation number 1 and equation number 2, you will get I1 equals to 0.66 and I2 equals to 0.442. These are the mesh currents. From the mesh currents, determine the current flowing through the 47 dash. Current flowing through the 7 ohms. Here that means I7 dash. So how you will calculate that? This current equals to, from the top to bottom, that equals to I1 minus I2. This current equals to I1 minus I2. From the bottom to top, that is I2 minus I1. If you apply KVL, then only you will understood that I1 minus I2 or I2 minus I1. This is I1 and this one is the I2. So here downwards current is the I1 minus I2. Next, second case also same thing, but here only thing is 5 volts. These equations are same. Only 5 volts is 0 and this 10 volts deactive will be active. So 10 volts is active. Now here minus 5 minus 7 I1 minus I2. There is no 5 volts. 5 volts is deactive. Same thing. Now here 12 I1 minus 7 I2. This 5 will be 0. This should be 0. This one. And next one 7 into I2 minus I1 minus 4 I2. Here there is no 10 volts. Here and here there is a 10 volts active. 10 volts. So this is plus 10 equals to 0. Now here if you simplify this, minus 7 I1 plus 4 I2 is equal to minus 10. This is equation number 1 and this is equation number 2. If you solve this, that current equals to I1 equals to minus 0.84 and I2 equals to minus 1.44. Now here current flowing through this I7 dash equals to I1 minus I2, same thing, but substitute these two currents, not these two currents. Now here these two currents, that value equals to 0.062. Now add these two currents, then you will get current flowing through 7. Now if you add the two currents, 0.24 and plus 0.602, that equals 0.842 is the current flowing through this 0.842 842 is the amperes is the total current. Now if you know the individual response currents, then you can easily determine total response current according to the superposition theorem. Here I7 equals to 0.842, that equals 0.24 plus 0.64602. Now if you multiply with 7, then you will get total voltage. Here in the question they mention voltage drop across 7 ohms resistor. So multiply with, this is not ohms current, this current into 7, then you will get the voltage across the 7 ohms current. Now fourth question, in a it is maximum power transfer theorem statement, a maximum power transfer theorem problem. In a series circuit, source resistance is 45 ohms and load resistance is RL with 20 volts DC supply. If RL is variable of resistance 10, 20, 30, 40, 50, 45, 50, 60, 70 ohms respectively. Calculate for what resistance of load maximum power is transferred and maximum power value, current and voltage drops in each case. So for that, first draw the diagram solution for this here. So this is the Thevenin's equivalent circuit. So means actual voltage source having some internal resistance. So this is source resistance and this one is the source voltage and this is the load resistance. Here load resistance may be a variable. Now here how you will calculate? If you see this diagram, this table, in this how many, this RL is variable. RL is variable, source resistance is fixed. The source resistance is a 45 ohms and the supply voltage is 20 volts. And RL is variable, 10, 20, 30, 40, 45, 50, next 60 and 70. Load resistance is changing. So what is the maximum power transfer theorem states that when load resistance equals to source resistance, then maximum power transfer to the load. That is the maximum power transfer theorem statement. Here, when at what resistance value, maximum power transfer to the load, because here source resistance is 45 means at 45 ohms resistor only, here power is the maximum that you need to determine. Here P maximum equals to, there is a formula Vs square divided by 4 into RL. This is a maximum power formula. Calculate for what resistance load maximum power is transferred. That one is at 45 ohms resistor. At what resistor? This is according to the statement, we can directly say at 45 ohms resistor there is a maximum power. So from the statement we can easily determine this. RS equals 45 means at 45 ohms resistor only there is a maximum power. Even 50 ohms, 60 ohms, less than that this maximum power. Now here maximum power value. So maximum power value is P maximum equals to Vs square, that equals to 20 square divided by 4 into 45, that equals to this one 2.217, that I will show you. Now what is the maximum power value? And that one is 2.17. This one is over 45 ohms and this one maximum power is 2.17. And calculate current and voltage drops in each case. So how you get, this is simple, only single loop circuit. In this single loop circuit we can easily calculate the current and voltage across the resistance. So simple equivalent circuit, that is IL. So now here 20 by 45 plus and this 10 ohms, current is changing. So this is fixed. This is 20 by 45 plus RL is changing 10 ohms. So that value equals to 0.363. And next if you take 20, that equals to this one 20 by 45 plus 20 and 20 by, that is 0.037. This one is 45 plus 20 and 30. Here you take 40 and here you can take 45 and at 50 ohms resistor 0.210, at 60 ohms resistor 0.190 and 70 ohms resistor 0.173. Now what about voltage? If you know this current, then you can determine voltage across the load resistance. Now multiply with this 10. So 10 means 3.63 and multiply with this 20, and 0.307 into 20 equals to 6 into 6.14, and this third one multiply with 30 and you will get 7 into 7.78 and multiply with 49.40, and this one 0.222 into 45, that is 9.99, and this one into 50, that equals to 10.50, and this one is the 60, and that is 11.40, and this one equals to into 60, that equals to so not 60, 70, that equals to 12.11. Now here power, how you will calculate the power? What is the formula for power? Equals to V into I, and if you multiply with these two and you will get the directly power, or you can do V into I, that means I into R, that equals to I square R, or V square by R. We can do, these are the three formulas. Here I am using I square R. So now if you multiply these two also, you will get the same value. So voltage across the 10 ohms resistor equals to 1.3 ohms. Watts here, this one is in volts and this one in amps, here watts. 1.317 watts for 10 ohms and 1.884 for 20 amps and 2.122 for 30 and 2.209 for 40 and 2.217 for 45 and 2.205 for 50 and 2.166 for 60 and 2.095 for 70. Now these are the powers. Now here if you observe this power and if you draw the graph between these, so this is the resistance and this one is the power. Here at what resistance power is maximum, here this is the power is the maximum. At 45 ohms resistor is a, just keep it in mind how power is first initially increasing maximum at load resistance equals to source resistance. When load resistance equals source resistance, what is the source resistance? Is a 45. Again this 1.3, 1.8, 2.1, 2.2 and 2.21, and after that decreasing, increasing maximum value and decreasing 2.205 and 2.1 and 2.095. So power is decreasing when even we are increasing the load resistance value, also power is decreasing. So from this table we can conclude that when load resistance equals to, this is the, when load resistance equals to, this is the source resistance, this is the RL, when load resistance equals to source resistance, and then maximum power transfer to the load, that is P maximum. P maximum equals to Vs square by 4 RL. So this formula, so 20 square by 4 into 45, that one is 2.17. From this also you can determine the maximum power value. Now fifth problem, determine the branch voltages using cut set matrix. So now here this is the graph. So for this graph, first determine cut set matrix. After that determine branch voltages. First, to find out this cut set matrix, first select any one of the tree. So now here tree indicates without any closed path, and there must be A, B, C and D. Total how many nodes here? 4 nodes and 6 branches. Now nodes are, number of nodes are here 4, that is A, B, C and D. Now 6 branches, number of branches are 6, that are 1, 2, 3, 4, 5, 6. So what about cut set matrix? Cut set matrix means here cut set matrix. So number of branches 1, 2, 3, 4, 5 and 6. So F cut set 1 and F cut set 2, cut set 1, cut set 2 and cut set F cut set 3. How you will determine the cut sets. So to frame that cut set, there must be first select any one of the tree to find out the cut set. So I am considering here this one. This is 2 and this one is 6 and this one is the 4. This is the tree. I am selected. Tree definition, there must be there must be all nodes A, B, C and D. There should not be any closed path. So the remaining are links, not twigs. Tree branches are known as twigs. So 1, 3 and this one is 5. So this is 5, this is 1 and this one is the upward and 3. Now here this is actual tree. This dotted line indicates the links and this lines represents the twigs. Tree branches are known as the twigs. Here 2, 6, 4 are the twigs. So number of F-cut sets are here total 3 because 2, 6 and 4 are twigs. So F-cut sets are depending on the number of twigs in a tree. Now here to frame that F-cut sets, there must be one twig. F-cut set to frame, there must be one twig and any number of links. So for this first one case, so possible number of F-cut set 1. Now this one F-cut set 1. So that F-cut set 1 direction should be this twig direction. And second one, this F-cut set direction should be, this is the F-cut set. So only one twig and remaining 2 links. And here also only one twig in the direction of 4th direction. This is the twig 4. And this is F-cut set 1 and F-cut set 2. And this is F-cut set 3. All are entering. If this direction is outwards, then you can take outwards direction for this F-cut set C, F-cut set 3. So entering. Now here from this we can easily determine if fundamental cut set direction and branch direction is same direction, take positive sign. If fundamental cut set direction and branch direction is opposite direction, so take -1. If not associated that branch direction and that F-cut set direction, then take 0. So +1 same direction and -1 opposite direction and 0 for not associated. So here, so possible number of here 1. So this 1, here 2 is a twig. So twig is always positive in the same direction. We have considered second direction, and remaining 1 is, so this 1 is upward and this one is the right side direction. This is in this direction, this is in the direction completely opposite direction. So F-cut set direction and this first branch direction is opposite direction, and 3 is not associated. This 3 branch and this F-cut set 1 direction is not associated, and 4th is also not associated, and 5th direction is like this, and this 5th branch direction is in this direction, and this F-cut set 1 direction is also like this. So this is the +1 and this one is the 0. 6th is not associated. Now next, second F-cut set 2 direction, 4th is same direction, next 4th is a twig, and 3 and 1 are same direction, 1 and 3, remaining all are not associated. Next case, third F-cut set 3. So same direction, 6th is the 1, so because 6 is the twig direction, and 3 is in this direction, sorry, 6th is in this direction and 3 is in this direction, completely opposite direction. So 3 is -1. Next, 5 and 6 in opposite direction. So 5 and 6 is opposite direction, means -1, and remaining all are 0, not associated. 1 is not associated, and 4th is not associated, and 6th is associated, that is twig, and 2 is not associated. Now this is the F-cut set matrix that is represented with a C. Now here using cut set matrix determine the branch voltages. Here this is the CT transpose into cut set branches. Here cut set branches here VT2, VT4 and VT6. So these are the cut set branch voltages. So now here twig voltages, and this is the branch voltages. Now here V1, V2, V3, V4, V3, V6 and V5. Now here, so transpose of C means -1, 1, 0, 1, 0, 0, 0, 1 minus and 0, 1, 0. Next 0, 1, 0, 1, 0 minus 1 and 0, 0, 1. How many total? 6. And these are the branch twig voltages VT2 and VT4 and VT6. And these are V1, V2, V3, V4, V5 and V6. Now here you can say that total how many voltages V1 equals to. Right, you multiply, you will get the branch voltages. Here V1 equals to minus VT2 plus VT4 and V2 equals to minus VT2, sorry, plus VT2. V3 equals to VT4 minus VT6. Next V4 equals to VT4. Just multiply with this matrix with this transpose of cut set matrix. Next V5 equals to, this is 0, VT2 minus VT6, and next V6 equals to VT6. So these are the branch voltages in terms of the twig voltages. Now, fifth question. Draw the graph from the incident matrix and write the tie-set matrix. So this is the incident matrix. Incident matrix is represented with A, and write down the tie-set matrix. Now here you can say that, so first representation 1, 2, 3, 4, 5. This is A node, this is B node, this is C node, and this one is a D node. Here in the incident matrix, if current is entering to the node, means this is A, suppose A node, and take -1, and current is leaving away from the node means that is +1, and not associated means with that is 0. So if you know this rule, then you can easily determine the incident matrix. If they will give the incident matrix, then you can draw the graph. Now here from the A node, this one is the branch 1. So now from the A branch to B, first write down here solution for this. So from the A to B, so B from A, this is a +1 indicates leaving current. From the A to B, leaving current. So A to A, from the A branch 1 is leaving. From the A branches 1 is leaving, and from the B branch is entering. So A to B should be like this. And same way here, this one, these two are completed. And another important property here, the summation of algebraic sum of any column in the incident matrix must be 0. If you know, this is most important property. Now here 1 minus 1 is 0, and -1 0 1 is 0, and -1 1 0, and -1 1 0, and -1 and 1 is 0. Any summation of algebraic sum of any row in any column in the incident matrix must be 0. Now here, so from the A to B is in this direction, from this 2 we can say, and next here D to B, next D to B, D to B, this is D to B, this is from the D to D2 is leaving means plus 1 and this one. Next B to C, C to D, this is C and D, C to B, and next D to C, D to C, next D to A, D to A. Now from this relation we can easily draw the graph. So here from first write A, B, next C, next D. Now see, this is the C. Now A to B is okay, clear, and next B to A to, okay, next C to D is clear, this one, and D to A is clear, this one, and next B to C is clear, this one, and A to D is clear, and D to C is clear, and C to B is clear, and D to B and D to B. This is the graph. Total how many branches? A to B is clear, and D to B is clear, and C to B, it should be C to B, and C to D, and A to D, D to A. Now this is the graph. A, B, C and D, A to B and B to D, sorry, D to B, B to C to B, and C to D, and C to B, and D to C. This is, it should be here. D to C and D to A. Now branches 1, 2, 3, 4 and 5. Now here this is the graph. From this graph you can easily determine the tie set matrix. How you will calculate, how you will write the tie set matrix? Tie set matrix is represented with B, capital B. So number of loops in a given graph. Here total how many loops? 1 and 2 in clockwise direction, I1 and I2. So loop 1 current I1 and loop 2 current I2, I1 and I2, and branches here 1, 2, 3, 4, 5. Total how many branches? Total 5 branches. So here this one branch, here this is loop 1, in this loop 1. So the loop current direction is always clockwise direction. So 1 and 1 is in same direction 1, and this 2 and 1 is same direction 1, and 3 is not associated 0, and 4th is opposite direction -1, and 5th is not associated. Next second loop, so 1 and 2 not associated, and this 3 is opposite direction and 5 is opposite direction, and 5 is opposite direction, 4th is same direction. So now consider, if it is same direction, take positive sign. If it is opposite direction, take -1. Not associated means that is 0. That is This is the tie-set matrix, loop matrix. It is represented with B. Now here, these are the branches and these are the loops, loop currents. Next, draw the graph from the incident matrix and write the cut set matrix. Same thing. A, B, C, D, A, B, C, D, 1, 2, 3, 4, 5. Now here, the directions here. So A to B, and C to B, C to B, and D to B, and next D to C, and next here D to A. Now here this is the graph. So from this you can easily determine the tie-set matrix. So for the formation of tie-set matrix, so select any one of the tree. This is 1, 2, 3, 4, 5. 2 branch. This is the 1 and B2. This one is B2C. This is a 2. B2D. Sorry. This is 2. This is 2. And this one is B2C. This is the 3. And this one D2C is the 4. And this one is the 5, A2. This is the 5. A to B is the 1. So 1, 2, 3, 4, 5. So total 5 branches. Now here, so this is the 1, this is the 2, and this one is the 3. So now here, these are the links. Only 2 links are there. So number of F cut sets are here. So this is represented with C, and this one is the F cut set 1, F cut set 2, and F cut set 3. 1, 2, 3, 4, 5, 6. So for formation of F cut set, there must be one F cut set, one twig, and remaining are any number of links. So here this one is F cut set 1, this one is in this direction, F cut set in the one direction, and this should be in the second twig direction, and this should be in the third twig direction. Now here, so 1 must be 1, and the remaining, this is 5. 5 is opposite direction, so -1, remaining all are 0. And here this should be this one, 2 is 1 and 5 is same 1, and this one is 4 is 1, remaining all are 0 in the same direction. And next this one, and here third is 1, and 2, 4 is -1, remaining all are 0. This is the cut set matrix. If cut set direction and branch direction is same, that is +1, and it is opposite direction, that is minus, and not associated means that is 0. So draw the graph and tree for a given network. Here to draw the graph, there must be so all elements must be replaced by short circuit, and only current source is replaced by open circuit. So short circuit means lines, all are replaced by lines. Here resistor is the element replaced by short circuit, and capacitor is replaced by short circuit. Voltage source is replaced by short circuit. and this current source is inductor is replaced by short circuit, and this one is also replaced by short circuit. There is no current source. All elements are replaced by short circuit. This one and this one and this one. The diagram must be, it looks like this. If you draw the graph, this is the graph. Here possible number of nodes 1, 2, 3, 4, 5 and 6, and branches 1, 2, 3, 4, 5, 6, 7, 8. Now here we can draw the diagram. Tree means tree, we can draw the diagram. Here, this is the tree. So A, B, C, and this is the 5 nodes. This is D. A, B, C, D, E here. So this is D, and this is the E. This is the tree, this one is the graph. This is the graph, and this one is the tree. Graph and tree. Next, 9th question. Reciprocity theorem. What is in a given network? So, verify the reciprocity theorem for a particular circuit. So now what do you mean by reciprocity theorem? When we interchange the source terminal and branch terminal, then the ratio of response to the excitation is same for both the network. Now if you see the diagram, so now here this is the A, and this one is the B, and this one is the C, and this one is the D, and this is A, and this one is B, and this is C, and this is the D. And I am writing one network I am taking, that is bilateral network. So here take one source plus n minus V, and here is the response. This is A, and this is B, and this one is C, and this one is D. And same way here, same network, no need to change anything. Now here draw this diagram. This is the response dash, and this is the voltage source. You can change the voltage value also. Now here this is the response I. The ratio of response to the here supply is the excitation, and this current is the response. Here is also I dash is the response for second circuit, and V dash is the supply excitation one. So the ratio of response to the excitation V is equal to I dash by V dash. This is the reciprocity theorem statement. Now here this is the network, and this is the network, only terminals. Now change the terminals. So this AB terminals and CD terminals interchange. So even if you interchange the circuit, this is the I and this is the I dash. So here the ratio of response I dash by 10 volts is equal to I by 10 dash by I dash by 10. The ratio of response. Here what is the excitation? 10 volts. Here what is the excitation? 10. Here what is the response? I1 and here what is the response? I dash. So this current divided by this voltage equals to, and this current divided by this current. That is the theorem statement. The ratio of response to the excitation is same when we interchange the source terminal and branch terminal. That is reciprocity theorem. To apply reciprocity theorem, there must be at least only one voltage source or one current source. Then only we can apply the reciprocity theorem. If there are two sources, we cannot apply reciprocity theorem. It can be applicable only single source network, not for multi-source network, and there must be a linear bilateral network, not for non-linear networks. So these are the two limitations of reciprocity theorem. If you apply for the circuit, so 10 into, if you apply, this is that I1 and this one is the I2. 10 into 1000 I1 and 2200 I1 minus I2. Now if you simplify, 3200 I1 minus 2200 I2 equals to 10. That is equation number 1. And next, so if you apply KVL in the second mesh, and 2200 I2 minus I1, that is minus, and 3200 3300 I2. So now if you simplify that, 2200 I1 minus this one and plus 5500 I2, that is equation number 1 and equation number 2. If you solve this, you will get I1 and I2. I1 equals to 0.004310 and I2 equals to 0.001724. These are mesh currents. So here we need only this response current. This response, how you will calculate here in terms of mesh currents, that equals to 0.00174. This is the mesh current, response current. Now this 0.0017424 is divided by 10. That is first response to the excitation we calculated. Now second one. So 1000 here, voltage source and branch are just replaced. Now here there is no voltage source, just same equation, but there is no 10 volts. 1000 I1 minus 2200 I1 minus I2 equals to 0. And if you simplify, is 3200 I1 minus 2200 I2 equals to 0. Next, 2200 I1 I2 minus I1, this is minus, and 3300 I2, this is current is flowing from plus to minus, that is minus 10. Now if you simplify it, 2200 I1, that is minus 5500 I2 equals to minus 10. Now here if you solve these two equations, equation number 1 and equation number 2, you will get, so I1 equals to minus 0.01724 and I2 equals to this one. This is the I1 and this is the I2. So now this is the I1 current is the 0.01724, this one, and I2 equals to this much. Now this much. Now here we got I1 value is minus. I1 value is minus means this I1 equals to minus of I dash, that equals to, now here from this we can say that I dash equals to 0.00174. Now if you see that here the ratio of response to the excitation is same, but here I considered only 10 volts and here 10 volts. Same voltage means here first circuit current, second circuit current is same. So now reciprocity theorem is verified. If you take 5 volts also, if you take 7 volts also, if you change the voltage value also, this particular property condition must be verified. It will be verified. So you can take 5 volts, 1 volt, 10 volts, 15 volts, 20 volts also, it will be verified. Here we can say this value and this value same. Why here is minus, this is downwards and this one is the upwards. Loop current direction is upward and this I dash current is downwards. That is the reason here we got minus value. Now 10th one. Calculate the current flowing through the 2 ohms resistor using Thevenin's theorem. Same steps as we discussed in this. So this is the circuit. Same. This is the current flowing through the 2 ohms resistor. So what about RL value? In the step 1, RL equals 2 ohms, in which the resistor in which current is to be calculated, where you want to find out the current value. Solution for this. Now here this is the equivalent circuit. This circuit is replaced by single equivalent circuit. So number of voltage sources, current sources and resistors are replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance. That voltage source is known as Thevenin's voltage and that resistance is known as Thevenin's resistance, and reconnect the load resistance. That load resistance equals to 2 ohms. So from the mesh analysis also we can determine I1 and I2. I1 minus I2 is this current value. But here in the question they mentioned Thevenin's voltage, Thevenin's using Thevenin's theorem only. So for that particular case, first convert that, remove the load resistance and convert that circuit into the single equivalent circuit. Now to determine this VTH and RTH, first there are same steps. So here to determine this, take for the given circuit. So this one, 2, 4 and 1, and this is 28 and this is 7 volts. And here this is the, remove the load resistance from a given circuit, calculate the open circuit voltage VOC, and that VOC is known as VTH and substitute in this. Now here So first 28 into, this is a I1 and I2. Here I1 equals to I2 because it is a open circuit. Same current flows to the 4 ohms and 1 ohms because it is a open circuit. Open circuit current is 0. Here if you apply KCL also, it will be satisfied. Same current flows to the 4 ohms and 5 ohms. 28 into 28 is equal to 4 into I1. 28 minus 4 I1 and plus minus VOC. This is plus and this one minus. Next, 4I1 plus VOC equals 28. This is the equation number 1. And second one, I1 equals to I2 because it is an open circuit. This is I1 and I2. This is current is 0. Now here 7 into, this is plus and minus, this is 7. 1 into I2 and plus VOC, that equals to minus 1 I2 plus VOC equals to 7. This is equation number 2. Now here if you solve this, you will get V equals to 11.2. This is 11.2. Now RTH, same thing. So remove the load resistance from a given circuit. This is the given circuit. All voltage sources must be, this is 2, 4 and 1. So remove the load resistance from a given circuit here. So remove this and calculate the R equivalent and short the load terminals. This is one. Short the voltage. So remove the load resistance from a given circuit. Voltage source is replaced by short circuit, and if there is any current source, replaced by open circuit, and calculate the R equivalent. Here 4 and 1 are connected in parallel, not in series, because we are concentrating on these two open circuit. 4 and 1 are connected in parallel. So 4 into 1 divided by 4 plus 1 equals to 0.8 ohms. Now this is 0.8 ohms and this is 2 ohms. Now here VTH, this current equals to IL equals to VTH divided by RL is 2 and this one is 11.2 and this is 0.8 ohms. Now here 2 ohms. So 4 ohms to 4 amperes are the currents. 4 ampere. This current flowing through this 2 ohms resistor is a 4 amperes. This is 4 amperes. Using mesh analysis also you can verify this. No Thevenin's, Norton's, nodal mesh also we will get same 4 amperes. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.